Hello students, in video number 26 we had an introduction to correlation and its types. Today I'll discuss one of the most widely used correlations is Pearsons correlation. This is part 2 of correlation series videos. I am Dr. Muhammad Zahir. Pearsons correlation measures the degree and the direction of the linear relationship between two variables. What is a linear relationship? I have already explained in video number 26. Please do watch that. Pearson product moment correlation coefficient R assesses the relationship or association between the two variables. The value of R ranges from -1 to +1. The sign minus or plus shows the direction of the relationship, and the number, for example, R is equal to 0.67 shows the strength of the relationship. We assess correlation by two techniques. First is the graphical method and other is correlation coefficient value. In graph, we get a scatter plot and see the direction of the relationship. This is one example of positive correlation, scatter diagram. This is example of negative correlation, and this is the example of no correlation where data points are scattered and you cannot see any particular pattern. Key points to remember. Remember, we rarely find perfect correlation. Individual differences and other factors may interfere with observed relationships. Correlation never implies cause and effect relationship. Do not put too much emphasis on significance in larger samples. Focus on the correlation coefficient. Always report significance with the coefficient in smaller samples. Applications of Pearson's correlation. There are certain applications where the Pearson's correlation is used. For example, one is prediction. For example, entry test scores and student performance. Can we predict students' performance from their entry test scores? It is used for prediction. For validity, correlation in similar measures, for example, measure of job satisfaction which is newly developed and an old measure of job satisfaction, do they correlate with each other? If the correlation is high, we say that the new measure of job satisfaction is valid. And third one is reliability. We see test retest reliability. For example, we see the scores on the same test from the same respondents at different time points, and we see the correlation between the two. If the correlation is high enough, we say that there is a higher test retest reliability. And then we also use Pearson's correlation for theory verification. We test and verify different theories. There are certain assumptions associated with Pearson's correlation. Pearson's correlation is conducted between two parametric variables. You must understand that two variables should be measured at a ratio or interval scale. The data should be normally distributed. If the data are not parametric, this might compromise the mean score, making it unreliable, and we could be reporting inaccurate outcomes if we fail to recognize this. It increases the likelihood of type 1 and type 2 errors. Be careful with the interpretation. Correlation doesn't predict cause and effect relationship. You cannot say that if the two variables are increasing or decreasing in the same fashion, so you can say that variable X is causing variable Y. Range of values affects the results. If you have taken certain range of the values, that means you have excluded certain values, so this particular range can affect the results. Correlation is extremely affected by extreme values. Be aware of the outliers and do check the correlation coefficient after you are checking the coefficient of determination. For example, a correlation R equal to 0.5 may look a higher value, but if we square it, it gives us correlation, the coefficient of determination, which is 0.25. It means that it only explains 25% of the variation. So a higher value of correlation is not necessarily a very good amount that is telling us any particular relationship. An hypothesis testing for correlation. In general hypothesis for the population, we use a Greek letter rho. H naught is rho is equal to 0 and H1 is rho is not equal to 0. It means that there is no population correlation and there is a real correlation. For specific hypothesis, when there is a specific prediction about the direction of the correlation, it is possible to do a directional or one-tail test. For example, if a researcher is predicting a positive relationship, the hypothesis would be rho H naught, rho is less than or equal to 0, the population correlation is not positive, and H1 rho is greater than 0, means the population correlation is positive. Let's take an example. Our research question is, are students' entry test scores related with students' classroom performance? Is there any relationship between entry test scores and student performance? Let us do it in SPSS. As we have already discussed, that we will first see a scatter diagram. Let's go in Graph Chart Builder and select scatter diagram and this simple and drag it here. Now take performance in the y-axis which you think is related with the entry test score. Take entry test score to x-axis and press OK. And this is a diagram of scatter plot that we have received after clicking to the scatter plot. Double click the diagram and click this particular symbol, add fit, and this will fit a line. So this shows that there is a linear relationship that might not be very strong, but the pattern is showing that there is a linear relationship between entry test scores and the performance of the students. Now let us do it in SPSS using correlation coefficient. We go to analyze, correlate and bivariate. We take these two variables to the variables box and make sure that Pearson is checked, and you can have a one tail test for this. Press OK, and here we see that entry test and performance are, here you can see this is entry test, this is performance, are very much correlated with each other, and there is strong correlation according to Cohen's 1988 formula, that is 0.536, and it is also, you can see the p value is 0.036, which is less than 0.05, and we can ascertain that there is a strong correlation between entry test scores and the students' classroom performance, and this result is also significant. So this is a simple example of correlation. Now we see how we interpret the results. You can see that our correlation coefficient was, first see the scatter plot, we have seen that. Check the information regarding sample size, there were no missing values. Determine the direction, we have seen the direction is positive, and the strength of the relationship is 0.5, more than 0.5, and we calculate the correlation coefficient of determination. We calculate the coefficient of determination and look for the significance level. Now let us calculate the coefficient of determination, which is called R square. This is 0.536. Let us do it. 0.536, square it. This is 0.28 and we multiply it by 100. This gives us that there is this relationship explains the 28.72% of the change in the dependent variable, which is performance, and you can see a lot of percentages unexplained. So now we are going to see how we check the correlation for group of variables. In many instances we have a number of variables, and how can we see the correlation among those variables? We have a file. This is a real research file, JCM, job characteristic model, and we can select some of the variables. We go to analyze, bivariate, correlation, bivariate, and you can select some of the variables from this, and there are a number of variables. I am just checking some of the variables, and we take the group of variables and we see the output. Here is the output. You can see that these are 1, 2, 3, 4, 5, 6 variables. Now how to check this correlation matrix? This is quite easy. Take this individual growth need. This is the variable. The correlation is checked for every variable against every variable. See, individual growth, it has a correlation coefficient of 1. Obviously, with the same variable, correlation coefficient R would be 1. With skill variety, it is 0.041. With task significance, this is 0.033. With autonomy, this is minus 0.101. With feedback, this is minus 0.073, and with feedback, it is 0.039 for this particular. And you can check for every variable against every variable. This is the way you can run a correlation test for a number of variables. Now we see how can we compare the correlation coefficients for two groups. This involves another method which is called split file method. Here you have to go in data and go into the split file. We, for example, split the file according to the gender. We want to see the differences of the males and females in this particular correlation. Click compare groups and take gender into group based on. Sort the file by grouping variables. Click OK. Now this file has been split into males and females in two groups. Now we want to check the correlation of any variables according to this split file. Let's go in analyze, correlate, bivariate, and we reset, and we select some other variables. For example, task identity, and I want to have another variable which is task significance. This. Okay. Now I press OK. Here you can see the correlation is given for females and for males, and the variables are same, task identity and task significance. You can see this, that there is 0.35 correlation. The strength of the correlation is fine. It is strong enough. It is not just strong, but it is also statistically significant. And this is for females. Now for males, let's see, the same two variables have a weak correlation which is 0.285, but this is again statistically significant. P value is 0.002, which is less than 0.05. So you can in the similar fashion check the correlation for the group of variables. You can check the correlation for different groups of the data like gender, male and female, and for different variables. So I hope you have understood how to check and how to calculate the correlation coefficient for Pearson correlation and how to see the results. You have to see two things: strength of relationship and direction of relationship. Hope you have understood how to calculate Pearson correlation for two variables, for group of variables, and for two groups. In the upcoming videos I shall show you other types of correlation. Take care. Allah Hafiz.